Find the domain and the range of the relation graph to the right. Well, this graph of the relation consists of two lines. The first line has an arrow on one end indicating that it continues this behavior forever in the direction of this line, and a solid point on the other. This one has a hollow point and an arrow. And the hollow point here represents that this point itself isn't part of this line, but the line that extends from it, all those points are part of the relation, just not this hollow point. Okay, well, let's go about first finding the domain of this relation. Well, the domain consists of all possible input values or all possible x values for this relation. The easiest way to find the domain is to project this relation onto the x-axis. Let's start with this first line. So this arrow indicates that all x values left of the confines of our graph here, this relation is defined for all those x values. In other words, for all x values less than x equals minus 5, this graph is defined. So we can sort of draw, if we were to consider this x-axis as a number line, we could draw an arrow here indicating this behavior. If we were to project this line on the x-axis, we'd see that we'd get a line that looks like this. This indicates that all x values less than or equal to minus 2 are defined for this relation. Thus, all these x values are possible inputs. What about this second line? Well, again, this arrow indicates that all x values to the right of the confines of our graph are possible input values for this relation. In other words, all the x values as x goes to infinity are included in the domain. We can represent this by an arrow on the end here. And we can also highlight all this section of the line. In fact, we can highlight all of this number line up to the point x equals minus 2, because this line doesn't include the point x equals minus 2. However, because this line does, because if we input x equals minus 2 here, if we draw a dotted line above, it would actually yield a y value. The y value it would yield is 4 up here. Then this point is indeed part of the domain. It's a valid input. Well, this number line shows us that any x value that we input, we always get an output. If it's x less than or equal to minus 2, then the output will be defined by this line. If it's greater than x equals minus 2, it'll be defined by this line. But either way, these lines combined mean that the domain consists of all real x. So we write all real x for the domain. Okay, let's consider the range. Well, the range is a set of all possible output values, or y values. Well, here, all values greater than y equals minus 4 won't be possible inputs. For instance, let's choose the value y equals 5. If we draw a dotted line along y equals 5, we see that there's no intersection with either of these lines. Consequently, there's no x value we could input into this relation that would output a y value equal to y equals 5. However, any y value less than or equal to 4 will be a possible output for this relation. So if we choose y equals 2 and we draw a dotted line, we see that it intersects with this part of this line, which means that if we input the x point x equals minus 3, we would get the output of y equals 2. So projecting this onto the y-axis, we get a point here, a solid point, because this point is solid, and then we'd get a line that extends down towards the bottom of our graph, and because we have these two arrows, it means that both these lines continue this behavior as y goes to minus infinity, which means we can draw an arrow here. Well, this segment represents the range, and we can write this range as y is less than or equal to 4.